Hey guys! Alright, so you just read the problem, and they want us to find the ratio of the volume of styrofoam to the volume of the brick, which we could then write volume of styrofoam or volume of brick equals some number, trying to find that number, and that will be our answer. Cool. Okay, so they make this statement, which is true. I totally understand. I just don't understand how they used this piece of information to come to their answer. Maybe you'll get it, and if you do, please share with me. That would be awesome. Okay, so they make this statement. They use the rule that if you have an object that floats, which ours does, yay, then the amount of fluid displaced equals the weight of the object, or the volume of fluid displaced equals the weight of the object. So we're going to write that. The volume of water, in this case, displaced, equals the weight of the object, which is the brick in our case. So, and if you're thinking, why the brick and why not the styrofoam? Well, we had some water. It had the styrofoam there floating. Awesome. But then we put a brick on top, and we're measuring the volume of water displaced as a result of putting the brick on top. So the brick is the object. The weight of the brick equals the volume of water displaced. So, cool. All right. Now, they jump to pointing out that in the problem, they tell us the density of the brick equals 1.4 times 10 to the third kilograms per meters cubed. Cool. And then we are geniuses and know that the density of water is like 1,000 kilograms per meters cubed, which is 1 times 10 to the third kilograms per meters cubed. Okay, so if we compare their densities, this one is 1.4 times bigger than that one. That one's just 1. So let's state that the density of the brick equals 1.4 times the density of water. Cool, we got this relationship. Okay, so then they sort of make a big jump and just state the next thing. And I figured out a way how they made that jump. So let me just say their statement. They say, since its density is this, its density is 1.4 times the density of water, and it must displace a volume of water 1.4 times its own volume. So it's like they made this, pointed out this relationship with 1.4 between them. So then they use that 1.4 thing with volumes between them. So how did they jump from density to volume? Well, if you look at the density equation, density is mass over volume, and you look at these two variables, they're inversely proportional. Inversely proportional. So if we increase this value, this one goes down. Or if this one's increased, this one goes down, or, vice versa. So what's the statement they make? They say that the displaced volume of water equals 1.4 times the volume of the brick. So before we said the density of the brick is 1.4 times the density of water. If we inverse that, we get the volume relationship. Now it's like backwards. The volume of water is 1.4 times the volume of the brick. So it's like this one's a larger value. than this one. Over here, it's this one's the larger value than this one. So it's because this inverse relationship. Density is inversely related to volume. So they're swapped. And that's the only way I could reason how they could jump from this statement to then this statement. Okay. So then they say, since this is only 1/2 the volume of the styrofoam, blah, 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 blah. So 1/2, they're pointing out that the problem says only 1/2 of the volume of the styrofoam is in the water, so is contributing. So the volume of water displaced is associated to only 1/2 the volume of the styrofoam. Only 1/2 the volume of the styrofoam contributes to this volume of water displaced. And so there's that relationship between those guys. And we already had this relationship going on. So then they are related in this way now. And this is then how it comes right to the answer. Let's do some math. So we have to get the V of S on top, right? Because we want to do V of S over V of B. So multiply both sides by 2, right? To, get that off. 2 times 1.4 is 2.8. 2.8 VB, volume of the brick, equals the volume of styrofoam. So let's write that in a ratio. So volume of styrofoam to volume of the brick. So he's the smaller one. He's the bigger one. So for every 1 brick, volume of brick is 1, 2.8 is the volume of styrofoam. And then just simplify that, 2.8. And that's the answer. Weird, right?